Student, in this video you see how to find prop reaction of a propped cantilever beam. Let's see the problem. A cantilever of length L carries a concentrated load W at its midspan. If the free end be supported on a rigid prop, find the reaction at the prop. Draw SFD and BMD. This is the propped cantilever. W is acting at the midspan of the beam. Length of the beam is L. So let's see how you have to analyze the beam. First, you have to consider the point load only without considering the prop reaction. So the deflection at B equal to YB. This is downward. Now next step, you consider only the prop reaction without considering the W. So here the deflection is upward, YB. Now we consider both the case equal. So we can write in this way. We know that downward deflection of beam B due to load WYB is equal to WA cube by 3EI plus WA square by 2EI into B without prop reaction. Now the upward deflection of cantilever due to prop reaction are neglecting the point load YB is equal to RL cube by 3EI. Since both the deflections are equal, so we get this equation. And from solving, we find the value of R. We get R is equal to 5W by 16. Now we draw the SFD and BMD. For that case, we require the value of R. At the fixed end, there is a reaction RA. This is upward direction, and prop reaction is also upward direction, and W is downward direction. So we can write RA plus R is equal to W. So here RA is equal to W minus R. Put the value of R, we get 11W by 16. Now you have to find out the SF. So SF at B, our R is 5W by 16. This is upward. Right side upward we take negative. So SF at B is equal to minus 5W by 16. Now SF at C. SF at C, here W is downward. So this is positive. So minus 5W by 16 plus W, it becomes 11W by 16. So here is negative, and here again positive, and at A is SF at A is 11W by 16. So this is like that. So our SF diagram is like that. Now we have to find out the BM. So BM at B is equal to 0. There is no distance. And BM at C is equal to R into L by 2. So it becomes 5W by 16 into L by 2. So 5W by 32. Now BM at A. BM at A is equal to R into L minus, this is downwards, W into L by 2. So it becomes 5W L by 16 minus WL by 2. So minus 3WL by 16. Now you draw the bending moment diagram. So at B is equal to 0. Here 5W by 32, this is positive, and here 3W by 16, this is negative. So here see the figure, there is a point where the bending moment changes its sign. So let's see how you have to find out the distance of point of contrafracture from the load W. So let's take the distance X. So this is X and this is L by 2 minus X. So this is a similar triangle. So we can write X by L by 2 minus X At this point intensity is 5W by 5WL by 32. So 5WL by 32. Here is 3W by 16. So here is 3W by 16. So from that we get x is equal to 5L by 22. This is the distance of point of contrafracture from the load W. Thank you.